Thank you for joining us. Our next presentation is Peeking Under the Hood: What's Driving the Autonomous Future?
Hi, everyone. Thanks for joining us. I'm the moderator of this panel, and I'm lucky enough to have four wonderful panelists here who have a unique view on self-driving transportation. Myself, I am the CTO of May Mobility, an Ann Arbor-based startup who has started running self-driving fleet operations in Detroit and Columbus, Ohio. But this is not about me. This is about our wonderful panelists. Starting to my left with Alex Mayer, who is the Manager for Software Engineering Solutions from ATAS Incorporated. Ram Maknis, VP of Product and Customer Success at Arbe. Emil Kadlec, Optical Scientist from Blackmore Sensors and Analytics. And Diane Lenzinger, CEO of Siva Technologies. So the way this is going to work, they're each going to give a 5-minute presentation, give a little background, some context to where they're coming from, and then we'll start just a more informal discussion about the industry. There's a sensor-heavy component here, but also some software, so we'll get into a lot of things. And then if you have questions, I'll be happy to take questions from the audience as well, although I do have some pre-prepared, so don't feel like you have to come up with some, and we'll be sitting here in silence for 5 minutes. So with that, Alex, please go ahead.
Okay, thank you. Thank you, Steve. So my name is Alex Mayer. I'm from ATAS. I work for ATAS since 2012. Since 2018, I'm in the US. So I come from Germany, so I came last year. And I want to give you a little overview about ATAS. So ATAS, we are market leader in powertrain calibration and measurement. We also acquired a couple of years ago a company called Ascript. They are market leader in embedded security, automotive security. And myself, I'm the application field manager for software engineering tools. This is bypass solutions, AutoSAR basic software, virtualization, and model-based software development tools. So ATAS is a subsidiary of Bosch. We are located in Ann Arbor, and as Bosch is our parent company, we are the tool and service provider for them, and we also take over successful corporate research projects for them. And one of these research projects is what we call SCODE. And you see that on the slide on the very left side. So the idea, Bosch research came up already 10 years ago. They started to develop this project in 2008. And at that time, models looked like you see that on the left-hand side. So that's really, this is model-based software development, just a small thing. So today, in today's development, they print it, and they probably even tape it together and put it on a table, put it on the wall. So you see a lot of complexity going on there. So Bosch corporate research motivation was to handle this complexity, and they come up with that SCODE solution methodology. And at that time, it was really about managing this complexity in these models. But nowadays, if we think about autonomous driving, all these sensors coming in, we have a lot of sensor guys here on the panel. So all these different requirements from different perspectives coming in, and somebody needs to manage and to handle software complexity, and this is where the SCODE methodology helps you a lot. So what they did, they developed a tool set together with a methodology. And once you apply these methodology, you see that in the middle, this is a 3-step approach. And the idea is, if you look at the left-hand side, this huge models in hierarchies and stuff like that, if you try to implement a new feature in there, it's almost impossible because nobody really knows what's going on in there. And on the right-hand side, you see they did this for a flex fuel project in Brazil already in 2016. And the implementation they started with for the flex fuel, that had 28, I call it decision points in the model. 28 decision points leads down to 270 million combinations. That's enormous. Nobody can test that. So the idea is with this code methodology, you come back and say, okay, what are the inputs to my system? What do I need to control in my logic? And even with that step, we reduced down to 8,400 only. So it's not about the decision points anymore. It's about, from a functional perspective, what does my system needs to do? And then it comes to the third step, where we really try to group into modes, saying from the requirements, what does my system need to do? And then it came down, okay, this flex fuel system only has to operate in 6 different operation modes, and that's it. So they reduced from a complexity of 270 million down to 6. And at Bosch, they already have it in literally hundreds of projects running. Some of them are already in series, some of them are still in development. And from ETAS, we can now, since last year, since 2017, oh, no, it's actually even last year. Yeah, we can sell this tool and methodology, and this is what we do. So we have a lot of customers in Europe already, and we are trying to also leverage our regions. So we have evaluation projects going on in Japan, in China, and also in the US, which I'm leading here. So the goal is at the end, when you have this model, this higher level model, you press a button, you get a new implementation, it goes down to the ECU, it generates code for you. So this is, I would say, the next step you need to do in order to handle this tremendous complexity we are facing in the future.
Thank you, Alex. So next we're going to hear from Ram, who is the VP of Product and Customer Success at Arbe.
Hi everybody, my name is Ram Mahnes. I'm with Arbe Robotics, and what we are doing is a super high resolution radar. So if we look at today's technologies of radar, they exist. We are using the plain old good radar technology, but we are taking it in 2 orders of magnitude higher resolution than what you have today in the radars that you have today in vehicles. That means that basically you can forget everything you know about the current radars, because this is by far giving you an image of the radar, of what's going on around you. So fusing it with camera and the radar picture and getting together a good understanding of what's going on around the vehicle, that's where we want to put the radar. So level 2.5, 2+, level 3 cars can really start drive in much safer way, in a trustworthy way, with the new cars that are coming in 2021 even. If you look at today's radars, the radar itself is a very good technology. It can see, of course, day and night. It can see in fog, snow, rain. Radar is capable of supporting all these weather obstruction, including direct sunlight, for example. But today's radar, they are basically giving you a very weak indication of what's going on around you. So if you look at a car in front of you, you'll get something that is equivalent to 1 or 2 pixels compared to a camera. Okay? What we are talking here is about getting 2 orders of magnitude higher resolution. So suddenly you get 100 pixels per an object that you have. And this will allow level 2 cars to be able to understand what's going on in front of them on top of what they understand today from a camera. For example, seeing the kid running between the cars and understanding this. Radars are really good at understanding movement of objects. Camera is not as good in this. If you have a car that is stuck under a bridge and it's in the shadow or inside a tunnel, radar can see it. Radar of high resolution can see it, and camera would not be able to see it. If we talk about all the false alarms that today's radars are giving, they are not able really to identify stationary objects. With imaging radar, with high resolution radar, you'll be able to understand exactly what is stationary, what is moving, what's the shape of the objects that are in front of you. If you're going into a traffic jam and there are several cars in front of you, understanding which lane is busy, which lane is free for you to go, this is something that today is considered to be impossible to do with radars. But we believe that with imaging radar, with the high resolution that we are bringing, this is possible, and we have live demos where we can show these capabilities, even understanding the shape of the truck in front of you. If it's an oversized truck, for example, then you will be able to identify this with our radar. Our solution is based on our own chipset, where we are increasing the amount of channels. If this is more technical in the radars, if today's radars are talking about 12 channels, we are talking about 2,300. That's why I'm saying it's 100 times more channels compared to all the radars that are out there today. This is based on our chipset. We are sampling our chipset, and it's available for the lead customers. We are engaged today with the OEMs and many tier 1s. We were founded 3 years ago, based in Tel Aviv. R&D is based in Tel Aviv. We are 70 people today, and we are in a beta stage, engaged with 12 paying customers already, and we have few more coming up very soon.
Great, thank you very much, Ram. Next we have Amol, and he's from Blackmore. And let's see if I can actually go to the next slide. All right.
Okay, thank you for the introduction. So we actually have a promotional video we're going to show you here.
At Blackmore, we aren't afraid of a challenge. We heard the need for long-range performance. We understand LiDAR must work in all conditions, and we knew our innovations could make autonomous technology safer, so our diverse team set a new bar for LiDAR. By leveraging the physics of coherent detection and decades of expertise, autonomous vehicles have a powerful new sensor capability, ranging beyond 200 meters, into direct sunlight, and resolving velocity on every single data point. Blackmore offers a new class of LiDAR, building on 2 decades of photonic integration techniques learned for optical fiber communications. Our hardware is mass manufactured today to automotive standards, with a focus on quality and reliability. Robust signal processing maximizes sensitivity. Paired with a rock-solid API, test, integration, and deployment were never so easy. Autonomous vehicle teams have a responsibility to put safety first. Discover Blackmore LiDAR.
All right, well, thanks for watching the promotional video there. So Blackmore Sensors, as you saw, is a FMCW LiDAR company. This is going to be a little bit different than what you're typically used to, which are usually amplitude modulated or pulse laser systems. Pulse laser LiDAR system sends a pulse out, that hits an object, and you wait for that to return. And from that time, you can calculate the range. FMCW does something similar, but instead of a pulse, we send out a continuous beam of light and put a waveform on that light. The return light is then processed using standard digital signal processing, and we get both range and Doppler. And that Doppler signal is used to calculate the speed of the object. So if something's moving towards us, we can sense that, and if it's moving away from us, we can sense that. There's roughly been about $1 billion invested into LiDAR. The majority of that's in AM systems, so your pulse LiDARs and your flash LiDARs. However, these sensors still have some sensibility to ambient light, So you have a system that performs better at night than it does in the day. And they're also susceptible to interference from other sensors. This is what FMCW does really well. It is immune to ambient light and has a very high tolerance for interference. We've also designed our systems to work really well at long range. So, past 450 meters, we can still see range returns. So this year, we're going to be producing 2 product lines, our autonomous fleet Doppler LiDAR, which is geared towards autonomous vehicles. This is a 4-beam system that'll produce about 2.4 million points per second. And it, again, can see past 450 meters. The horizontal field of view will be about 120 degrees by 30 degrees. The scanning resolution of that's 0.01 degrees. We're also coming out with our LiDAR development product, which is the next slide. This is more of a general LiDAR system, not necessarily for autonomous vehicles, although it could work for that. We're gearing more towards robotics, robo-taxis, and something that I'm really interested in is long-haul trucking. If you think of long-haul trucking, you need to stop a very large vehicle at highway speeds, so you need to see very far. And that's something we're working on, a 1 kilometer distance capable LiDAR system. So just as a review, we're an FMCW LiDAR company, and we provide LiDAR data that gives you both range and speed of your target.
All right, thank you very much. And then moving on to Diane from SIVA.
Thank you. Hi, everybody. My name is Diane. I'm the CEO and co-founder of SIVA Technologies. We are based both here in Detroit and also in Seattle, Washington. I'm actually a Detroit girl myself. I grew up about 15 miles north of here in the Pontiac-Bloomfield Township area. So what we do here in SIVA is we enable hardware perception stacks, which sounds really technical, so I'm just going to break it down for you from how we think about that. So how many of you have a car that has a backup camera in it? Okay, great. Maybe you have a little bit fancier vehicle that has something that helps you maintain your speed or avoid collision, or tells you that there's a car that you're not seeing on your side mirror and you're about to do lane change, and it's like, whoa, don't do that, right? Okay, so this is actually kind of the early indicator of what you might even call level 0 autonomy. There's a human in the car. That human is getting advice from these cameras, sensors, maybe even LiDAR units on the car. And the space that we find very interesting is what happens when these digital eyeballs of the car get blocked. So if you can imagine, if you're driving the car and somebody covers your eyes, you have no data, you can't figure out how to drive. Well, cameras, LiDAR, and different sensors on vehicles are now the eyeballs of the car, and the space that SIVA works in is how do we keep these digital eyeballs clean? So what we have developed is a system that heats standard washer fluid efficiently, and then it intelligently distributes it around the exterior of the vehicle to flash wash these cameras or sensors or LiDAR units in fractions of seconds. So if they get dirty, how many of you have ever had to wipe down your backup camera? So mud, grime, dust, bugs, very common on the front end of the vehicle, freezing rain, snow, ice. These are all environmental conditions that actually block the data funnel for these hardware systems to take in data and have the advanced driver assistance systems and automated driving systems give the driver either advice or full-on driving decisions. So we keep that top end, really the physical part of the data stack, physically clean, and we call this the environmental fence. So you might have these ADAS systems on your cars today, but AVs down the road are going to have probably dozens of these systems, maybe 3 or 4 dozens of these hardware pieces on them. And they're really, right now, can only operate in almost optimal environmental conditions. So most of the testing of autonomous vehicles happens in Arizona and California, and they say, ooh, fog is so hard to do. Well, come and deploy here in even Columbus or Detroit, and you'll see what real environmental challenges look like. The OEMs that do testing here and the full stack startups that do testing in northern climates, they typically do it in very constrained environments. When it gets to be really rough conditions, they actually stop the testing. So what SIVA is interested in solving is how do we keep these perception surfaces physically clean so that we can keep the data flowing, keep the vehicles moving, and we can actually, in the end, eventually scale autonomous vehicles and mobility consumption.
Great, thank you so much. So that's some context for the questions I'm going to ask today. I think you'll agree that these are some of the experts in this space, and I think you would want to know their answers to these questions. So first question is for Alex and Ram. So from your perspective, what is the single biggest challenge facing teams developing AV technology today?
Yeah, so from my perspective, it's really, we have the legacy world, we have today's cars, and we need to integrate all these new technologies, self-driving, electric vehicle, hybrid electric, not to forget about legislation, security. Security is really important if you have all these connected vehicles.
Wait, I'm going to interrupt because I said single.
Single?
Single.
Oh, I'm sorry.
I have to moderate something.
So then the single, I would say, that's complexity, really. The complexity of all.
Okay.
Yeah, and really manage that. This is something we need to find a solution for.
Great. Ram.
Yeah, I think the biggest challenge right now is how are we really getting to a trustworthy technology here? How do we get people to really believe that it's possible to do autonomous vehicles and not autonomous driving, and people getting into these and trusting that this will get them to the right place? And to me, it starts with the endpoint of the sensor itself. The technologies of the sensor that is out there is still not ready to really give these software and algorithms to understand what's going on around them and take the right decisions. We tend to think that it's already there. I think camera is pretty much there. I think other sensing technologies are must-have in order to get the right decision, and it's still not there.
Great, thank you. So now on to the hot takes section of the event. So for Diane and Emil, what's your most controversial opinion on self-driving cars, or the thing that you feel like you go the most against the grain from the industry?
Yeah, well, I'll take a very biased answer to that. So that there is a solution to Mother Nature today. So I talk to people who work on hardware perception development. They have sensors, cameras, LiDAR in development, and they say, we can see through dust or grime or mud or, bugs or whatever, but we talk to OEMs who have done integration with these technologies, and the truth is a signal might be able to come out, but it's if it's occluded in any way, coming back, any kind of a surface playing with the radome or the different elements of that surface, if it's blocked, it's not necessarily intelligent enough to pull in enough data. So I think there's a great opportunity still to continue to develop hardware in this space, and then we also have to figure out ways so there's hardware perception stack, there's software perception stack, and I actually think there's going to be a cleaning perception stack that we'll have to figure out, which will be a combination of the types of systems that we have in development that deploy washer fluid, probably heated, could be surface coverings, it could be advanced wiper blades. There are ways that we're going to have to keep these clean because the hardware itself is not able to do it completely on its own in advanced, challenging conditions.
Great.
Well, I think my answer is kind of a simple question. I kind of like driving. It's pretty fun. But when I'm driving at 3 a.m. to the airport, it'd be pretty nice. But I think what Diane brought up is although we have great technology right now, it's not at the point where we can really have full autonomy. So it's driving a lot of technology further right now, which is really great in the LiDAR space, in the radar space, in the cleaning space, as well as in the software space. So it's really exciting. And although right now it's this weird thing, I don't know if I really want to give up my driving privileges. It still is pushing technology forward, and that's really, really interesting.
Great. So next question, I'll go back to Emil again, and I'll have Alex answer as well. So what's sneaky hard about self-driving cars that nobody's really talking about you know, with the devil's in the details, and everyone's talking about, you know, the big challenges. What are the little challenges, or the things that are really hampering the day-to-day?
Sure. I think one of them, so right now, you know, people have achieved, like yourselves, current autonomy, but getting that on the highway is another extreme challenge because you have to see things from far away. So having high-resolution scanners like the radar system we saw today, like long-distance LiDAR systems, those are really sneaky hard because that technology still has to be advanced from what it currently is.
Great.
Yeah.
Alex?
My answer would go in the same direction, so I completely agree with you and also with Ram. I say what's really hard is making all these things reliable and bring it together that you can really rely on your car, your software, your autonomous, whatever, is really doing what you want, and it does that in a safe and secure way. So I think getting it on the road is still hard. So we read a lot about, we hear a lot about what they do out there, but bringing it to mass production and couple it with today's serious development, I think that's still hard to do.
So the title of this session is called "Peeking Under the Hood." So I wanted to lift a little bit of the sheet a little bit and ask some of you guys, you know, what is something about your business that might surprise the members of the audience? You know, there's things that press releases that come out and demo videos, but you know, for Ram and Diane, what is something that might surprise people in the audience to hear about what it is you guys do?
Yeah, so we get many times people, the surprised face when people hear that we are actually making our own chipset. So equivalent to Texas Instruments, NXP, and so forth. We are developing the chipset because the technology that is out there today is not capable of getting to the resolution in a cost-effective way that we want to get with the radar. So what we did, we leveraged the most advanced RF technology to develop our chipset in a most condensed way so we can save space, which means that we save cost, that we leverage this in order to give the highest performance to the OEMs and the tier one. So I'm getting sometimes still the surprise face that we are not leveraging chipsets that are out there, but we needed to go and develop, and we are sampling now our own chipset.
So for SIVA, it might surprise you that we're actually in market today with just a conventional heated washer fluid system in the commercial vehicle space. We are actually using commercial vehicles to build out sales channels and prove out the requirements that we expect to have in the passenger and personal vehicle space. I think commercial vehicles are a really interesting place for startups and early stage companies to play, and we've found that this standard system that almost has nothing to do with advanced driver assistance systems and autonomous vehicles are really an early indicator of what we believe will be fleet consumption of personal transportation down the road. So you'll often find that, that companies that play in the passenger personal vehicle space are deploying, could be an aftermarket or in a commercial vehicle uptake, just to kind of test the waters there. These are their full-stack custom vehicles that are manufactured for very specific use cases. And so often startups and early-stage companies can go in and deploy and get data and pilots earlier than we might be able to in the established OEMs, where things might move a little bit more slowly. They have to service a broader set of consumers. So.
Great. Thank you for the candid responses. I think that people might find that surprising, so thank you very much. All right, let's see. Going back to Ram and Emil, I'm going to put our thinking caps on for a moment here. So if I had a magic wand, and a very magic wand at that, and I waved it, and all of a sudden there were level 4 self-driving cars everywhere, but they just appeared overnight, what would the consequences of that be? What would be the social and the technical or otherwise unknown consequences of that be without having that ramp up?
Okay, so I think that even if we'll see those just around us, I think people will still have hard time getting into them and trust them. Really, it's about trust here. I think Asimov is the one that says that we will not accept robots harming people, okay? And even if everybody will, it will be fully proven that self-driving car is safer than human-driven car, I think people will still not be able to accept accidents, for example, caused by autonomous vehicles, even though it's like 1% of the accidents that when humans are driving. I think this is a big psychological barrier that even if we'll have those cars just running around us, we'll still have.
Yeah, I definitely agree with Ram. If you look at what's happening in like Arizona and people cutting these vehicles off and giving them brake checks, there's going to have to be some social acceptance of those vehicles. I think give it a week, and all of a sudden people are going to say, "Hey, this is pretty nice. I can drive to the gym and text while I'm doing that." But technically speaking, you're still going to have to evolve how people locate those and how the roadway is going to work. Let's say that there's still human drivers on there. That's a big unknown for those systems still. So there's still a lot of technical development that would have to happen at that point as well.
Great. Sort of taking an external look here for Diane and Alex, what companies other than your own are doing great things and we should keep an eye on? So basically, who should we have invited to the stage? What would you have wanted to hear from them?
Oh, okay. So at this table, I actually find what WaveSense is doing is fascinating. So they're using imaging technologies to read below the street surface to figure out positioning and automated driving for vehicles. I find this absolutely fascinating. I wish that I had thought about that. I think they should be here on this panel. So
Great.
you call them up. They have a booth here. So.
Okay, from my perspective, so I have more the development view of it. So I see a lot of other companies going towards virtualization, which is very interesting, and I think we should definitely have a look on them to see what they can do in a virtual world, in a virtual space with virtual LiDARs or radars. I recently heard something about it. That's pretty complex, what's going on there. So that's pretty interesting, I think.
Great. Let's see, I don't want to hog all the time here, so I do want to make sure that if there are audience questions, we can get to those. So are there any questions for the panel from the audience right now? I still have more in the queue, but this is the time. You guys are shy.
Hi, I'm Margot, and I have a question for Blackmore. I come from Corning, and I was wondering, because you were saying optical communications, like optical cable, so I'm wondering how that plays into your LiDAR systems. Is there actual optical fiber in there?
Yes, so the reason we say optical communications is it's a coherent detection technique. And so what we do is coherent detection techniques. So the application space is very similar in the hardware. As we further develop our own chips and whatnot to do FMCW LiDAR, those are going to look very similar to what you have in the telecom space at a high level. And so that's why we were talking about it there.
Great. Any other questions? All right, well, I've got some more. Thank you very much. So this one is so important, I want to ask everybody on the panel about it. We're in a very innovative, fast-paced industry, but safety is obviously critical, and we talk a lot about having a safety culture. I know we do at May, and I'm sure you guys do too. How do you maintain that safety culture among the pressures of trying to deliver quickly with a lot of competition?
Should I go first?
Whoever wants to jump out now, because it's going to be for everybody.
I go first. So safety, coming back to what I presented earlier, the SCOTE product, we actually even have a paper and a certification for it that if you apply these methodology, you already fulfill some norms of the functional safety, ISO 26262. So if you reduce complexity, you already check some of the boxes for functional safety. So I think that's a good way to enforce you and to help you bring functional safety into your products, into your software.
But is adherence to ISO 26262 enough? I mean, that's like following the rules. Like what? Let's talk about safety culture, right? How is it ingrained in everything that you do?
Yes. So at ETAS, we develop the software development tools. So what we do, for instance, to bring this product to the market, to the people, we start with consulting, we start with training and say, okay, this is the way you have to use it in order to be really sure it's applied the right way and you don't produce any results which are not safe. So that's our approach here. But at the end, we are not really responsible for the product going out on the road. Yeah.
Yeah, I think, of course, there are all the standards, the ISO 26262 and the ASIL and the Q100 and all these things, but I agree, it goes above and beyond it. It's about a culture of safety. And for us, for example, we are trying to solve safety issues by having a high-resolution sensor. Okay, so of course, we don't want the sensor to be the cause of a safety or a quality issue. So it starts really from all the way from the architecture of the solution to the development, to the software side of it, to the integration, to the physical really side of it that really need to take into account all the safety measures and countermeasures that are needed. And on top of it, we, for example, we are a startup company, so we are relatively young, but it doesn't mean that we cannot bring people that have years and years of experience in doing automotive, in the automotive grade quality coming from the automotive industry, and then the collective experience of even a startup company can be as of a mature company, that people that went already several times through these processes of getting a solution from the incubation phase to a mature product.
Yeah, I think safety's got to be ingrained from the top down, right? The CEO's got to show, hey, we're trying to make a product that's going to make the road safer, and so I want you guys to think about that every day and realize like the impact that you're going to have on lives. Because if you can save one life, like, hey, we've done something that's important, and it's something that's very good. So safety's got to be ingrained culturally from the top down, especially at these startup companies that are moving really fast, and maybe trying to push things really hard. You got to take a step back and say, hey, are we actually doing this product? Is it improving people's lives? Is it increasing the safety?
Not to get too deep into it if you're not comfortable, but do you have an example of a time where your CEO really stepped up and asked a question? I realize that could be sensitive.
Put me on the spot.
Yeah.
No, something that we do that's really fun and it keeps people involved is, hey, you have quarterly meetings. You say, hey, somebody pointed this out on the system. Here's a $50 Amazon card or something along those lines. Like, good job, and you can ingrain it in people. So I think that's something that's really fun and that we do.
So at SIVA, we talk about internally the 5 T's, which we see as the foundation of our corporate culture. So team, right technology, right timing, right traction, and then number 5 is trust. And to me, the trust is really the measure of the safety culture. So you can implement processes and you can decide, these are the certain regulations that we need to follow, or here's how we technically define safety. But if you don't have the trust in that technology, you're simply not going to have the adoption. So we talk a lot internally about building trust among each other as teammates, among ourselves and our potential customers and our partners. If we're not getting a really good stream of communication from them about how they evaluate technologies and how they decide whether or not a technology is ready to be adopted, if they don't trust us enough just as human beings and partners to share that information with us, we're never going to be able to build safe systems and really drive this technology adoption. So we believe that safety is interesting, but in the end, it's actually measured by the trust of the people who are the decision makers. And consumers in the end, people who are going to be consuming mobility services or buying vehicles with these types of technologies, if they don't trust the vehicles, regardless of whatever ratings they get, they're never going to actually buy them, and they'll never be monetized. So for us, it's not so much safety, it's really the fifth T of trust.
Great, thank you for that insight. All right, this is my last question, and I'm gonna pose it to everyone as well. Don't have to go down the line. Whoever is most inspired, go first. So, we always think about, the end result of AVs is maybe full level 5 anywhere, anytime, self-driving cars. But is that the only way to spell success? What does success look like for this industry, and how would we measure it?
I think, if you don't mind if I jump in.
Yeah.
I think the easiest way to measure that is improvement of people's lives. If you make, I'm going to take my grandfather, for example. The guy should not drive. But now if he has a way to get to the grocery store, that's fantastic. We've improved his life. So I think if you can measure it in not just getting to L5, but improving people's lives, that's a really important thing.
Great.
I would agree to that. So picking up the trust, if I trust a car to drive my daughter safely to her friend and back, that would be success for me if I don't have to worry about that.
So I think we'll see gradual improvement. It won't happen in one night, okay? But we'll see gradual improvement, more and more autonomous time that our private cars will drive, and we'll trust them gradually more and more to longer duration. But for me, the dream, okay, if we go, maybe it's because I'm traveling a lot, but my dream would be that I call this autonomous car at 8 p.m., I go to sleep and wake up in the next morning where I wanted after a really good sleep because I could trust it, and in the right spot that I wanted it to be.
So I actually think that success for AV is where autonomous mobility becomes almost like a utility. So Bill Gates used to talk about how high-speed internet and bandwidth should eventually become a utility, that every person should have a PC on their desk in their home. Now we have mobile devices that give us access all the time. But really, for me, the ability to, whether it's a person who has limited mobility or a child that you feel like you can trustfully put them in a school bus to get them to their vehicle and wave goodbye on this autonomous vehicle, and people can access mobility at the right price point or lack of price point at some point and get safely to where they need to go. This is really going to be the biggest driver economically, globally, that we could ever experience. And it's the same way as like electrification 100+ years ago going out into the central west of the United States. This will enable economies in ways that we can't even imagine. But it's really all about access more than anything.
Great. Thank you. So that brings us to the end of this panel. Let's thank the panelists, and thank you guys for being a good audience. And I'm sure these guys will be hanging around a little bit in case you want to do a little bit of a deeper dive afterward. But thank you very much for your attention.